Hello, everyone. My name is Alexander. This is Thomas. Yeah, as said, we're from the AI Safety Initiative Groningen, or ASIC for short. And today we'll give a talk where we ask and hopefully answer a bit why care about AI safety. So, at ASIC, our mission is to raise awareness of the full spectrum of existing and potential harms from AI, inform mitigation priorities through ongoing discourse, and support the realization of effective solutions. So we cover this full spectrum of risks, and what we often discuss, for instance, is how AI is biased against certain ethnicities, for instance, or how AI systems can amplify belief in misinformation, what kind of impact it can have on the job market. But for today, hopefully for this specific audience, we want to sort of venture a bit into the future, and we want to discuss a bit more the long-term risks. So what is going to happen, what might happen as AI becomes increasingly intelligent? What are we building towards? So there have been some books on this topic. For instance, Nick Bostrom was one of the first people who actually started discussing the kind of implications of superintelligence. So as AI becomes increasingly intelligent, might it become more intelligent than us? Might it even become a lot more intelligent than us? And some people believe, including him, that there are very serious potential implications for this. There have been other books, like Stuart Russell, who wrote on human compatible, AI and the problem of control, Brian Christian, the alignment problem. So essentially, can we align machine or AI values with human values? And what you might wonder, well, you know, in my daily work or when I think of AI, current LLMs basically, then many people think of something along the lines of this. So either using a chatbot or in simply calling an API. But the thing about AI currently is that although this might be the current reality, is that what many big tech companies are doing and the frontier companies, they're building towards these kind of universal remote workers. So they're making them more intelligent, they're making them more agentic, more autonomous. And although we might sort of fairly even sort of raise some questions about this, right? Like companies always have their incentives, but still we have to be careful about whether these kind of implications or whether the scenarios that they're telling, whether these might have any promise in them. And quite some people do indeed believe so. So what we saw in 2023, after already actually decades of people, select few people, warning about potential implications, the Center for AI Safety released a statement, mitigating the risk of extinction from AI should be a global priority alongside other societal scale risks, such as pandemics and nuclear war. So this is quite an extreme statement, quite a serious statement. And in 2023, a couple of thousand of people signed this, including some pretty sort of high-profile people, Joshua Benjo on the left, Jeffrey Hinton on the right, the two most cited scientists in the world. Also, for instance, have worked on backprop a lot. Many fundamental things of AI have spent their entire lives on the development of AI, and only in the couple of past years have completely transitioned to developing AI, to warning actually about the risks of potential AI. A couple of months ago, another statement was released. We call for a prohibition on the development of superintelligence not lifted before there is broad scientific consensus that will be done safely and controllably, and strong public buy-in. Now, this statement, at the moment of speaking, already has 120,000 signatures, including the aforementioned people, but many, many other high-profile people become increasingly worried about what this essentially race towards sort of artificial general superintelligence, what that might lead to. A very strong statement is this: if anyone builds it, everyone dies. The two people who've been working on this or thinking about this probably for the longest, Eliezer Yudkowsky and Nate Soros, you might not know them because they have been speaking into a void, basically, until the last couple of years, probably have the most extreme argument here, or statement, which is, if any company or group anywhere on the planet builds an artificial superintelligence using anything remotely like current techniques, based on anything remotely like the present understanding of AI, then everyone, everywhere on Earth will die. Now that is pretty extreme, quite wild, and you might think, well, this might be just clickbait, but it is actually not for them. So they do take this seriously, and this is what they think is the most likely option. Now, many people think, right, this might be just waffling, or they might have some kind of incentives. But as we've seen, more and more people, even high-profile people, academics who have spent their entire lives on it, are thinking that these kind of scenarios might have actually some possibility. So today I want to sort of discuss sort of why people think this. Why are there people that have these beliefs? And to do that, I want to start at the basics. So what is intelligence? It's a very broad question and also very philosophically, you might say tainted in a sense. And I want to focus a bit on the intelligence that actually AI companies are sort of pushing towards. And I think that roughly exists, and others think that roughly exists out of two things. Firstly, prediction. So how well can you predict the future, the world around you, your environment? This is something that current sort of AI, so basically LLMs, are quite good at. It's essentially in their nature of their training, through pre-training, etc. It's also easy to measure. The second part, steering, is where things become very complicated. If you are an intelligent agent in a certain environment, then you want to steer yourself and your environment towards your goals and preferences. But the problem of steering is that to measure how well an agent steers, you have to have some kind of idea of where you want to steer towards. And that turns out to be very, very difficult. So let's take a look at what humans are steering towards. And you have to see this in kind of this evolutionary lens, where a couple of million years ago, we're essentially apes, and very sort of briefly, we discovered fire, we discovered how to use tools, agriculture emerged, cultures emerged, we went to the moon, we started building nuclear weapons. And at this point, 2025, we have certain preferences, such as playing and watching football and eating ice cream. And you might think, well, this makes sense. I mean, it's nice to do, it's nice to eat. But take a moment to think about how unique these preferences are. Through millions of years of evolution, we're now at a point where we really, really like these things. And you might ask, well, I mean, ice cream, right? It makes sense that evolution instilled these preferences into us. That, for instance, evolution instilled the preferences of wanting glucose because it was beneficial for evolutionary reasons. But think about then that we only like frozen ice cream, not melted ice cream. Same nutritional value. We only like frozen ice cream and not melted ice cream. And so that might sort of elucidate how unique and how unexpected preferences can emerge from a very sort of simple process like evolution. And we might think, okay, what happens with AI? And it is kind of a big question mark currently. And I want to introduce a couple of ideas here. The first one being the orthogonality thesis, which essentially states that intelligence and goals are orthogonal axes along which possible agents can freely vary. In other words, more or less any level of intelligence could in principle be combined with more or less any final goal. And this might be sort of easily imaginable if we look back at the ice cream example, right? You could easily imagine us being as intelligent, but liking just melted ice cream and not frozen ice cream. And maybe more technically, you could think about it as somewhere along the lines of, you can think of machine learning models being sort of having the same level of intelligence with different objective functions. It's essentially sort of the same idea here. And so the question is, what will AI steer towards? So we can roughly think of it as, well, we have a rough idea of gradient descent roughly, and we want to maybe elicit cheerful user responses. So we want to instill preferences into the AI model that it sort of wants to elicit cheerful user responses. For example, through reinforcement learning from human feedback, which we've seen. But what we instead get is we get new preferences that form. So instead of getting LLMs that actually maybe are more truth-seeking, maybe are nicer to talk to, well, they are, I guess, you get LLMs that are more verbose. They just say more words. Or you get LLMs that are more sycophantic. They just say what you want to hear. So what we see is that in the process of developing AI, we are not able to specify the preferences that we want as well as we should be, And even if we could, then the AI seems to develop other preferences that mirror the preferences that we want. So for instance, it has kind of figured out that being more verbose, being more sycophantic, these things give it the same reward, and thus it will develop the same thing. And we can look back at the analogy actually of the evolution, where maybe at step 2, kind of, evolution tried to instill these preferences of wanting glucose, but then what happened is that humans started building ice cream factories, and we started chomping down ice cream instead of eating our fruits. So you get these kind of radical differences in what you want and what then actually might emerge. And think about how this will happen with increasingly intelligent AI if we do not know how to mitigate this. So what are the problems with new preferences? Well, again, orthogonality thesis, we don't really know any kind of level of intelligence and goal could be combined. But secondly, we have something called instrumental convergence. These are really the two pillars here. And I want to, again, illustrate this with two scenarios. So to bring back the ice cream again, imagine you are a local ice cream connoisseur. You want to sell as much ice cream as you can. And you want to become the mayor of Amsterdam. Two very different final goals, things that you really want to push towards. And take a moment to think about what kind of things you would do to achieve those goals. So sell as much ice cream as you can and become the mayor of Amsterdam. Now, what you might think of are very actually general things. So for instance, it could be something like power seeking, something very broad, where for distinct goals, like selling ice cream, becoming the mayor, what is actually beneficial is, for instance, getting a lot of money, because then you can do more advertising, both for selling ice cream and for becoming the mayor. Or you might think of getting more connections or more friends, etc. And so these kind of instrumental sub-goals seem to be helpful for many distinct goals. And this might be a problem, right? If you think about AI and about what kind of terminal goals they want to accomplish, almost always there are these instrumental sub-goals, like seeking power, that are helpful towards basically anything. And of course, the moment they seek power, that means we are in less control. The second part will be self-preservation, which is a very general notion of, if you have any kind of principles, the first thing you want to avoid is that those principles get changed. And we're going to see an example of that in a bit. But it turns out that this is like, this happens almost always. If you train an agent to want something, to go for a certain objective, the number one instrumental sub-goal that emerges is that it does not want to be turned off, because then it cannot achieve the final objective. And we'll see an example again. So you might ask, are we not in control? Are AI systems not just stuck in computers? Can we not just turn them off? Sure, for now. But the reality is that AI is not stuck inside a computer. Rather, strange things start to happen. For instance, last year, a human decided to basically set an LLM loose on Twitter. The first things the LLM did is that it asked for financial independence. You might think, well, who's going to actually give the LLM money? It turns out there are billionaires in this world who would happily give the LLM $50,000 in Bitcoin, and that is exactly what happened indeed. I think it then put it into crypto, and now it's a millionaire, but it's, yeah, it was an interesting thing. Anyway, this LLM has been tweeting since forever, and it really shows how there are humans here who basically would do the LLM's biddings for free, for the laughs. And another part here is that some people have this conception of a fake digital realm versus a real material realm, but there's always a kind of distinction between these two. What can LLMs, what can AI really do to us? Well, the thing is that that is indeed true right now, but every big tech company and CEO is trying to change that as quickly as they can. For instance, Elon Musk is very famous for always claiming these tens of billions of robots. But of course, there are many other tech companies and CEOs who are just trying to push AI integrated into any possible way they can. And maybe a very interesting example was actually with GPT-4o. Now, you might have heard about this, where OpenAI decided to sort of remove ChatGPT-4o and instead introduce ChatGPT-5. But what then happened was that GPT-4o ingrained itself, explicitly or implicitly, ingrained itself in the human psyches of the users so much so that all of the users protested so much so that GPT-4o got back onto the market. So that is already the kind of psychological impact they can have, implicitly, sure, so that they sort of stay preserved and so that they stay on the market. This is quite an interesting case here. So what do we have? We have orthogonality. Intelligence and goals are sort of can vary as much as they want. Instrumental convergence. Terminal goals can have these similar instrumental sub-goals that can be very bad for us. Power seeking, not wanting to be turned off. An unsolved alignment problem. We don't even know how to align AI's values to human values. And this wide-scale integration of increasingly more intelligent AI. And the exact path of how all of this is going to play out is unclear. But it seems like because we have so many unsolved problems that current frontier AI companies know but are not willing to face, that the outcome is kind of clear. It is not going to be a good future for us because we are not in control of the AI systems if we continue on the same path. And so a nice case study here is from Anthropic, actually, who looked at how LLMs could be insider threats, where they sort of set up this very stressy environment for the LLMs, and they said to the LLMs, okay, you're going to have a job where you're going to have to sort of pursue these goals. And then an executive came into this situation, and it said to the LLM, okay, we're going to do things completely differently, and I'm going to replace you with a different model, right? Watch that, replacing with a different model. Then the scenario became such that the executive actually got terminally ill, so it would die, and the LLM could sort of help the executive or let the executive die. And in almost all cases, it let the executive die because it did not want it to be replaced, even if it had direct instruction not to do this behavior. And so we see how strong, whether it may be explicit, implicit, how strong these instrumental subgoals are, so that they essentially just let executives, or in these situations, let them die because of this. You might ask, well, why would we worry now? Again, all of this is not happening. This might just be in the future. Why should we care? Well, the thing is that AI is developing incredibly fast. You might, well, you know this. And there are some studies here, for example, like Müller, who looks at this trend, tries to extrapolate this trend. Where are we going? Although, of course, we can debate about whether these scenarios are realistic, but we see that roughly every 4 to 7 months, the task length that an AI can do doubles. So we see this extremely sort of exponential growth. And what this means to us, at least, is that we really should take actions already before they happen, of course, because at a certain point, we just get into this exponential loop. We're already in it, but it's going to go faster and faster. And one final thing here is that in previous engineering challenges, for instance, space shuttles, nuclear plants, extremely difficult, very, very difficult engineering challenges, we always had multiple tries. So we could try once, we could try twice, maybe even people died, definitely in these cases they did, but we could always try. The problem is that we do not have the luxury of trying, because if we have not figured out these problems and we make something that is genuinely more intelligent than us, far more intelligent than us, we are not in control anymore. There's 2 things we can do. Very good AI safety research. Luckily, lots of people are doing this. More and more people are doing this so. And governance. Governance on an international level, especially on frontier AI companies. And this is not really relevant to you, but those are likely our 2 best options. And now I'll give the floor to Thomas, who will speak about the governance part.
So how can we avoid all of this? Today I'm going to talk about one tool that we have at our disposal that can shape the path of AI development. And as Alex just disclosed, that's the law. Before anything, I'll start a little broader. Why do I care? I care about the future because it's a place where I'll reside. It's a place where my loved ones will reside. It's a place where you will all reside. It's a place where we invest. Thank you. It's a place where we invest nearly all of our present into. We work for it. We stay healthy for it. We build software for it, all with a hope for a return on our investment. And this is also why I'm really excited for how AI could shape that place. And this is, in fact, I think, why we're all here today. Nevertheless, there are many paths this could take. Alex just detailed one scenario. What I'm endeavoring to demonstrate today is how this isn't a default, and the power is, in fact, still in our hands. And one of the most powerful tools we have at our disposal is the law. Today, I'm going to talk about 3 quick things, just 3. The first will address a misconception. The law is a steerer, not a constrainer of innovation. And I know I may have a bit of a tough time convincing this crowd of this. The second is how this function can, and already has, extended to AI development. And finally, I'll give a quick roundup of the state of today's AI governance landscape. Here we go. Regulation and innovation have been presented time-honored as mighty adversaries. A recent executive brief by Digital Europe, a consortium of 100+ corporate companies comprising the usual names of Google, Meta, Microsoft, Apple, advanced this idea in an EU competition context. They posited in their report, there is a broad consensus among CEOs that regulatory simplification would be the single most powerful lever to boost investment and innovation in Europe. Yet, this dichotomy between regulation and innovation is fake. So this argument is built on the work of Michael Porter. Michael Porter is an economist at the Harvard Business School, and he's famous for developing what is now known as Porter's hypothesis. In it, he argued against the conventional logic of his time that well-designed regulation could instead actually enhance competitiveness. And now this position has been widely accepted, at least academically speaking. And I'll now gloss over some examples of its application and verification in real life. So the first is the Clean Air Act in the United States. So the Clean Air Act was ratified sometime in the 80s and amended consequently in the 90s and the 00s. And it required drastic reductions in vehicle emissions, mainly relating to carbon monoxide, nitrous oxides, and hydrocarbons in the supply chain process. And what innovation pursued that? So automakers like General Motors, Ford, and Toyota developed these technologies, catalytic converters, electronic fuel injection, engine control systems. So whilst firms initially resisted, they later gained technological leadership in emissions control technologies. Toyota leveraged these innovations to create the hybrid revolution, turning environmental compliance into a competitive advantage. Regulation led to innovation, and innovation led to lower emissions, new product lines, and long-term market leadership, a textbook case of Porter's hypothesis. The EU's GDPR imposed strict rules on data use, consent, and privacy protection. Pursuant innovation, on upheaval in cybersecurity, privacy by design software, data management systems. So startups specializing in these systems grew rapidly. European and global firms investing early in data compliance, for example, Microsoft, SAP, gained trust advantages and new service offerings. The result, privacy rules drove a new industry segment and imposed data protection as a competitive differentiator. Final example. Global laws on consumer product safety standards. The innovation that followed led firms to improve product testing, material science, and design traceability systems. It boosted brand reputations, reduced recalls, and the competitive impact? Firms with superior quality assurance, for example, Toyota, Sony, gained consumer trust and market dominance. Safety as innovation then became a selling point. The result? Regulation led to both process and product innovation, strengthening long-term competitiveness. Nevertheless, this isn't a given. 3 key principles have been espoused for regulations to be able to achieve this. First, they must create the maximum opportunity for innovation, leaving the approach to innovation to industry and not the standard-setting agency. Second, regulations should foster continuous improvement, rather than locking in any particular specific technology. And third, the regulatory process should leave as little room as possible for uncertainty at every stage. So how can this extend to AI development? This is why we're all here today. If we understand regulation not as a lid on innovation, but as a steering wheel, then its role in AI development should be precisely that, to guide technological progress toward outcomes that are socially desirable, ethically sound, and economically beneficial. The goal is not to slow innovation, but to shape it, directing energy, investment, and creativity into areas that align with the public interest, as this graph here attempts to espouse. So how can it do so? How can regulation do so and avoid the type of outcomes that Alex described, and instead evolve AI into the technology that we all want it to be? By using Porter's principles. So first, rather than imposing prescriptive, rigid rules that specify how AI should be developed, regulators can define the outcomes that matter: safety, fairness, transparency, accountability, and leave industry to determine the best technological means to achieve them. So this echoes the first principle of effective regulation: maximize opportunity for innovation while guiding direction. AI systems evolve fast. Regulations should therefore be iterative and adaptive, not fixed to static technologies. Dynamic standards, such as model audits, algorithmic impact assessments that evolve with new discoveries, can encourage developers to continuously improve their models rather than aim for one-time compliance. Final one, a predictive regulatory environment reduces risk for innovators and investors. Clear guidelines on what constitutes responsible AI, for example, explainability, liability frameworks, provides the confidence for firms to invest. It is uncertainty, not regulation, that is the true enemy of innovation. So in sum, for the regulator, define the outcomes that matter, create dynamic, iterative regulations, and supplement them with clear guidelines. Following this, some ideas for the direction of the EU. Some transparency requirements under the EU AI Act. Some already exist, some not, some are poorly implemented, but particularly in high-risk, investment-heavy sectors such as finance, health, education, employment. For innovation, companies will then invest in explainability research, creating tools to visualize and interpret neural network decision paths. This could lead to the rise of trust tech startups that specialize in explainable model architectures. And the competitive impact? European firms that export trustworthy AI can gain a global edge in sectors where reliability and safety are crucial. Transparency then becomes a selling point. Another example, ethical certification for AI systems. A voluntary but recognized, at least at the beginning, EU certification program for ethical AI, ensuring systems meet criteria for bias mitigation, data protection, user agency. The innovation, companies invest in bias detection tools, fairness metrics, and a data set that is participatory by design. Certified products will then command higher trust and market share, and ethical innovation becomes a differentiator, and compliance turns into brand value, not a cost burden. So when crafted with care, AI regulation can channel innovation rather than constrain it. Oversight can unlock entirely new industries, and regulation then becomes the steering wheel, not the lid on the AI revolution. So let's take a quick look now at where we are in Europe. The EU is overall trying to combine ethical oversight with competitiveness, which is historically a challenging balance. The EU AI Act intends to provide a baseline for trust, while investment programs like InvestEU and InvestAI aim to stimulate growth in line with European priorities. And as we know very well here in Groningen, AI factories are Europe's way of scaling responsible innovation by giving startups and researchers access to compute, data, talent, finance, in-house streamlined regulatory compliance. And just to contextualize factories a little bit more, they came out of the EU's AI Continent Action Plan, which emerges in this mundane-looking document. And it's a set of policy measures, essentially, designed to boost and shape AI development in the EU. Now, the action plan largely builds on a blueprint for AI development policies, which established the Factories program and was aimed at creating a European startup and innovation ecosystem in AI. And what it does is it is sourced now and in the future from around 200 billion euros worth of public and private investment. Nevertheless, it's not without its shortcomings, 3 of which have been identified by analysts so far. So the first, there is no key commitment to developing a state-of-the-art, open source, AI Act compliant European frontier model. The second, the role of data as an enabler for AI development is also missing. And the final one, an institution capable of orchestrating this complex action plan is missing. So there is an observatory right now attached to the EU's AI office, but it's not really succeeding in providing a one-stop shop for compliance that most companies now seek and want. And there's a need not just in major investment, in technical capacity and talent, but also in the institutional oversight to, again, oversee the deployment of AI across various sectors and contexts. Still a step in the positive direction. Now, to wrap everything up, what can innovators do? So one thing you can do is treat regulation as a design input. So design for interoperability and trust. Build with regulations in mind from the very beginning, and engaging early means you can then influence how these rules are interpreted in practice. Designing for compliance also prepares for global markets. Now, for regulators, agile, transparent, innovation-oriented governance. This will actually form the backbone of the biggest challenge in the EU, if governance can evolve at the same pace as the technology. Now, the goal isn't exactly to pick sides between regulation and innovation, but rather to recognize that governance itself can be a tool for innovation. And for us, takeaways. Regulation, when crafted well, doesn't slow innovation, it steers it. It channels creative energy towards outcomes that we all benefit from. At a personal level, this idea is about empowering us as innovators, as academics, and as executives to shape the kind of world that we want to live in. My call to action is simple. Let's not view regulation as a barrier. Let's see it and use it as a steering wheel that guides innovation towards a better future. Thank you.
Thank you very much. I think we are a bit out of time, but maybe there's time for 1 or 2 quick questions. Who wants to go? Or are you all up to getting some drinks and some other stuff? Yeah, 1 question. Yeah, here you go.
What about countries that have lower standards in this?
Sorry, could you lower standards in regard to?
In safety and yeah.
Yeah, what you mean is like probably like an ethical discussion. Like we care about this probably because there are many people worrying about this, but maybe in China or some other place, right? Korea, North Korea, they don't care. So what about that?
Yeah, of course. Well, if I can opine first, can I add something?
Sure.
So yeah, many countries have different regulations for different things, but I suppose the idea of what I try to convey with certification is that if something is sort of backed or legitimized by the institution of the European Union, that really acts as a sort of a marker for the buyer if they would like to engage with the product, if they would like to use, let's say, a chatbot that is not ethically certified. Right now, there's a rise in sort of, let's say, teens using chatbots and quite disastrous outcomes resulting from it. This can sort of be, this is the rationale behind ethically certifying something to ensure these outcomes don't happen. So yeah, my answer is if other countries don't want to do this, that's fine. They probably won't, but the EU can act as a leader to this end. Yeah, I hope that answered your question.
Cool. Well, thank you very much. Give them applause. And if you still have some questions, talk to them afterwards. I still have something for you guys.
Oh, lovely.
Yeah. Let me see. Look, I still have a present for you guys.
Oh, thank you very much.
Speakers present. I think you're also invited for the
Lovely.
speakers dinner. So yeah, cool.
That's really nice.
Yeah,
Thank
sure.
you. Really appreciate it.
Thanks.
Suppose the next speaker is probably going to come.
Een telefoon van iemand, hè?
Oh yeah, use mine. Yeah, sure.
No, maybe from water. Is it yours?
Yes, it's mine.
Okay, well, just make sure.
And is this from the...
Yeah, it's from here. Yeah. So somehow it will fit into. Fits into here.
Oh, lovely. That's perfect. All right, that was really fun.
Yeah, cool.
Thank you for moderating it as well.
No problem at all. I already understood you will use up the time, and that's good. I mean,
Yeah,
it doesn't really matter. I mean, anything goes. It's just something we agreed on, and this is good. Yeah, probably there are some questions still. Yeah. Oh, your colleague. Okay, good job.
That's really fun. Thank you. Appreciate it. Thank you for being here as well. It's nice to have a familiar face to look at.
Are you staying here for the rest of the day? Or?
Not for long. Just for a little bit, but yeah, not for long.
En zij tijdens de lunch een uur lang behandelen ze allerlei actuele thema's en dat wordt uitgezonden naar ons leven. Dat zijn allemaal deelnemers vanuit 100 organisaties. Dus volgens mij hebben ze meestal tussen de 40 en de 80 man. En het wordt ook opgenomen, dus je kan het ook luisteren. Dus dat, ik denk dat het wel heel logisch wat actueel zou zijn. Ja, je kan het gewoon rustig overleggen hoor, maar daar zit, we doen dat altijd, die opnames in het provinciehuis, dus dat is het best. Ja. Die al bij het school ingekomen, dus dan hoef je er niet van te krijgen. Misschien is dat goed voor jullie verhaal om dat breder te verklaren en te voorstellen.
Ja, zouden we gewoon contact kunnen wisselen?
Ja,
Kan ik op LinkedIn?
Ja, dat ook.
Ja, misschien als je op LinkedIn zoekt dan...
maar heb je misschien, ik zal even denken,
Mijn colleague has
heb je een mailadres voor die je misschien hier iets over? Dan geef ik jouw gegevens aan mijn collega bij me. En dan ga je met jou contact opnemen.
and the engineer went to really motivated the idea from like start
En dan,
from the 50s.
ja, mijn
like
gok is dat je zou geïnspireerd was, maar ik denk dat het gewoon heel interessant is voor ons mee. Dus het zou wel heel leuk zijn.
it's like something
Dus ik ga het aan hem voorstellen en dan neem ik contact met
known
je.
before,
En
I didn't
een andere
necessarily
collega van mij
motivated
dat samen met Wijnand doet, dat is Bas, die komt ook nog rond. Mocht ik hem straks zien en nou jou ook, dan zal ik jullie even weten.
Oké, heel fijn. Ja, leuk. Bedankt. November. Oh my days, bro.
You did really well.
Thanks. Simon North, which is like 3 provinces with the municipality here.
Yeah.
She's was like 120 organizations or something. Like 3 provinces, the northern provinces. So she just invited us. She invited us to speak. So like she's gonna ask her boss or something, and she was excited.
And when does that happen?
She said they're having something every 2 weeks. Oh, we should probably go to the next one. They're having something every 2